In the previous video, we've seen that we may formulate a goal programming problem with the objective function of minimizing the sum of penalties that we get because we underachieve the goals. Now I'm going to talk a little bit more about the objective function and see in other cases that probably not only when we underachieve the goals, but when we exceed our goals, sometimes we may also have penalty on that. So let's take a look at it. So this is the previous example that we've seen. And then here, as I've mentioned before, only Si minus variables appear on the objective function, because in this case, we only have the penalty when we underachieve the goal. So when we do not reach the goal of the audience, either from high-income men, low-income people, or high-income women, then we get the penalty because we do not reach that goal. But depending on the case, it's also possible that we have penalty for Si plus variables too. So let's see the next example. Suppose we modify the example such that the $600,000 budget is a goal. And then there is a penalty of $1 for each dollar that we exceed the budget. So for every $1 you exceed the budget, you will get the penalty of $1 as well. So if we use this modification, it means that in our objective function, we will have a penalty of $1 times S4 plus. Because remember, S4 plus means that it's the amount by which we numerically exceed the ith goal. So the fourth goal is the budget constraint. So S4 plus, it means how much we exceed that budget that we set at the beginning. And then notice the sign here is in the objective function, it is plus S4 plus, because here we get the penalty of $1 for each dollar that we exceed the budget. So the sign should be plus here, although in the constraint, the sign is minus. So in the constraint, it's minus S4 plus because it shows how much we exceed the budget. But in the objective function, the sign becomes plus S4 plus because it is talking about the penalty. Now, given the formulation, the modified problem, and then given the optimal solution for that formulation, there is a statement saying that in the optimal solution, we exceed the HIM high income man by 0.33 millions, and we also exceed the budget by 33.33 millions. Is this statement true or false? I will give you the answer after the pause on the video. So the answer is true because you can see that the variable S1 plus equals 1/3, and then S4 plus equals 33 and 1/3. So the statement is true. So up to here you see a goal programming problem that may be formulated as just like a usual linear programming problem, such that you may also use the ordinary simplex or maybe big M or two-phase to solve this kind of goal programming problem. The key here is just that you need deviation of variables, and then you need to define the objective function based on those deviation of variables. Now in the next video, we are going to see another type of goal programming in which you can't really use the usual simplex algorithm or big M or two-phase to solve that type of goal programming. So see you on the next one.